Now, if I sound a slight exasperated as I go through this, it's because I came in Friday morning and made a video explaining how to do this that apparently most of you put on in the background, wrote down something on your video sheet, and said good enough. So, learn how to do it now. So, in this case, we notice that the mirroring, the reflective side of the mirror, is on the opposite side of the mirror as the focal point. That seems weird. Of course it's weird. We expect, from the concave mirrors, that the mirror should reflect everything through the focal point, but in this case, it can't because this side over here of the mirror doesn't reflect anything. This is the reflective surface, okay? The point of the focal point here is this shows kind of where all of the rays would have come from if they were able to move through the mirror. Now that sounds a little bit confusing, but the point is every one of the rays that bounces off this mirror is going to get deflected in some way, but it's going to get deflected as if it came from the focal point. Okay? The C point is still there because it still has a center of curvature, because it still would make a sphere if you extended the mirror all the way around 360 degrees. But the whole point of the focal point here is the rays are going to bounce off as if they came from that point, if they could move through the mirror. Now, just like in our concave mirrors, the first one that we draw, and a lot of times it's called the P line because it is parallel to the principal axis. It comes from the top of the object right here. Make this red. It goes parallel until it hits the mirror, and then it's going to bounce off. So it's going to go like that, right? Now, it's going to bounce away. In what angle does it bounce away? That's where the focal point comes in, okay? Now, for you guys with your straight edges, it's a lot easier. All you have to do is lay your straight edge so that it intersects the focal point and where the ray hits the mirror. For me, it's a little bit harder. I don't have a straight edge. I have to kind of draw a line and go off of it. So I'm just going to draw a dotted line here to give me something to go off of, and then adjust it a little bit, because that's not going to be right. I'll have to adjust it. But the point is, we should line this up so that the focal point and where this ray hits the mirror are in line with each other. Keep adjusting this till we get a little bit closer, something like that. Okay? Now, you don't need to draw this entire thing. I just had to draw that so that I have something to go off of. This is what we want to do right here, though. Okay? We want to draw where this line or this ray bounces off. So this is the path that the light actually takes. Let me adjust that a bit. Something along those lines. Okay, so the light comes off this thing's head, the object's top. It's going to bounce off of the mirror, and it's going to go away like that, in line with the focal point. And really, I just use this as kind of a backup, so I'm going to get rid of this for now. That's the way that light goes. Down? No. Again, the dotted line that I drew there was just to give me the angle that it's supposed to come off of. You guys should just put your straight edge so that it intersects with, take your protractor or whatever. You know what? Let me grab a meter stick. It's apparently what I say doesn't really connect. Let me show you. Okay, once you've drawn the parallel line over to where it hits the mirror, you take your straight edge, you throw it on here, and you go from F to where that line hits, and then we draw the ray coming off of there, bouncing off. Okay? That's the first ray. I'm making sure everybody's on the same page here. perfect time to leave. Now, how do we draw the second ray? On the concave mirrors, you go you go straight towards the focal point until it hits the mirror, and then it comes off parallel, right? It's like the opposite of this one. This one goes parallel until it hits the mirror, and then it's going to ricochet. This one goes towards the focal point until it hits the mirror, and then it goes parallel. Now, so you would line this up like this, right? From the top of the object, you would draw a ray that goes like this, and then it should come off perfectly horizontal. Okay? Now, again, I have to do it a little bit differently because I can't, I guess I could try to trace this. We'll see what happens. Okay, like that. And then we should have a parallel line that comes off like this. Okay, there's my purple lines. So any rays that come off right towards the focal point will be hit off parallel to the line of axis. Are what equal? The angles here? Yes, they would be equal because they are both towards the focal point. Well, we're not done yet. Okay? Now, here's the way the light actually moves, right? The light goes from here, it bounces off the mirror, and it goes winging off this way. The light from here bounces off the mirror and goes parallel. But there's no places where these two lines intersect, right? If your brain is looking at it, remember, the light goes, it bounces off the mirror. You're looking at the light that has bounced off the mirror. So you're looking at this ray here and this ray here, the ones that came off of the mirror. That's what your eye sees, and that's what your brain interprets. Your brain assumes light moves in a straight line. So when we look at this, your brain is going to go, well, this one right here looks like it came from behind the mirror way back there. Okay, so you need to draw a dotted line behind the mirror to show where your brain thinks that stuff came from. And same thing with this one. This is the ray that we actually see. Your brain assumes it came in a straight line. So your brain assumes it came from back here. And now we see where the image is formed. Okay? The image is formed at this intersection of where your brain assumes that those rays came from. So right here is where we would draw our arrow. Again, we draw from the principal axis up to the intersection point right there. And that's where our image is formed. How would we describe the location of this image? The location. Between the focal point and the mirror, but we should also specifically say behind the mirror. So behind mirror, between mirror and F. Okay, is this image upright or inverted? Magnified or reduced? Reduced. It's smaller than the actual object is. And is it real or virtual? It is virtual. no light actually passes through this point, right? All the light stays on this side of the mirror. It bounces off. It's a virtual image because that is where our brain is interpreting that light coming from. Do the next one. So go on to case number 2. Do the steps in the same way. Okay, parallel till it hits the mirror. It goes off in line with the focal point. Towards the focal point until it hits the mirror. It comes off parallel. Then draw where our brains would think those lines came from. The intersection point is where the image is formed. Okay. If this takes you more than 5 minutes, you're doing something else. As everybody picks up their phone. Where's your object, though? You should draw it on there. Or, I mean, the image. Sorry. Where's the image? No, that's the object. No. The image should be where, see, you didn't make this line dotted. You should have. Where this line and this line interact. So the image should be drawn right there. Okay, that looks good. Makes sense. Oops. So where is your image? Right there. Yeah, so you should draw the arrow on there. I feel like this is not. Oh, I see. This is where your image should be formed, right here, right? Yeah, right there. That looks good. Well, no, this is good. So, yeah, upright, reduced, but it's got to be a virtual, right? Okay, looks good, Cheyenne. Ah, yeah. Okay. It's looking good. You guys got those? Yes. Good. Did you just come in? Did you just come in? Did you just come in and I missed it? Huh? No? You've been in here the whole time? Or you were in study hall? Or, not study hall, homeroom. Oh, that's right. I got confused. I'm sorry. You aren't messing with me. Maybe. Now's the time to challenge me to a game, I guess. My mind's going. Okay, let's go over the answers here. So here's number 2. Okay, so we should have an object formed right about there. Location, same as above, right? It's between the mirror and F, behind the mirror. It's upright, reduced, and it's virtual. Hey, guess what? All convex mirrors produce the same type of image. All convex mirrors produce upright, reduced, and virtual images, always. So convex mirrors are, you still have to be able to do the ray tracing, and that can be a little bit more confusing because you have to think of these virtual rays, right? But you know they have to be upright, virtual, and reduced. because there's no other type of ray that can be produced, or image, I mean. We're going to see that a little bit as we mess around with these mirrors today.